Okay, just looking at simultaneous equations, we'll first look at what we know already. You see I have a lovely picture of an apple there and a banana. I had to label them apple and banana because they weren't clear enough, as you can see. But let's have a look at this apple for a second. And we'll do algebra around this apple. So we're going to say two apples are equal to, let's give a number of €6. They're expensive apples. Well, our prior knowledge tells us that one apple is equal to, obviously, half of that 6, or 6 divided by 2. 6 divided by the number of apples. So that apple is equal to €3, and that's fine. We could do loads of examples with the bananas as well, but that's what we're coming into this chapter with. And if you're not sure of that, just let me know. We'll come back to that. But that's what we have. So one apple is, we can solve for the price of an apple is basically what we're saying before we even start this chapter of simultaneous equations, or solve for A. Now let's look at another problem here. So now we have 1A plus 1B is equal to €3. So we have an apple. Well, we'll stick with the apple and the banana analogy. So we've 1A plus 1B, one apple, or 1 plus 1 banana is €3. And we're trying to figure out what A is and what B is. So we looked at this in class and we said, or we looked at a similar example and we said, loads of different answers for A. So A could be €1, and then that would mean that each banana is €2 to make up the €3. And it could be the other way around. We could have 50 cents and 2.50. There's infinite amount of ways. It could be 2.99 and 1 cent. Really, but we're just not sure. Okay, and yeah, so we're trying to figure that out. And to be honest, we can't. Maths doesn't allow us to solve if there's two different variables. So we need more information, basically. Again, if we look down at, I'm going to scroll down here now a little bit, and I have my pictures of my apples and bananas back. You see them there at the left-hand side. And I have the algebra for those apples and bananas just here. So we have one apple plus 1 banana is €3. Now we have 1 apple and 2 bananas are €5. And all this, although this looks like it's more work, it should be a nicer problem because there's more parts of the jigsaw here for us to solve and to see exactly what things are. So if we think about this logically, let's try and figure out what's going on here. So we've an apple and a banana are €3. Then an apple and 2 bananas are €5. So what we're trying to do is see what's the difference between the two different, we're calling them equations here. Okay, and that's where the word simultaneous equations kick in here as well. So we've two different equations, which are similar, but the values are the same. For the values for A and the value for B is the same. So the cost of that apple is the same in both equations, the same. The cost of the banana is the same in both equations. So let's see, what can we do? And one of the rules that we looked at so far is, well, we could just subtract or get the difference of these two different equations, or if they were receipts, two different receipts. So we could subtract the apple and the banana and the €3 from the apple and 2 bananas and €5, just to leave us, and I'm sure some of you have this done in your head already. So that's going to leave us with 0 apples. There's no need to write in 0 apples because there's also 0 of loads of other things that we haven't written in. Plus 2 minus 1 is just 1. B is equal to €2. So in that way there, if we just took away one equation from the other equation, well, I'm left with the apples cancel out, and I'm just left with 1 banana is equal to the difference of the costs, which is €2. Okay, and that's how it's solved for that. And that's the first rule of simultaneous equations that we took down, where I can add together the two equations at any stage. And so I have a banana, it's €2. Now let's try and solve for an apple. So let's write out that top line again. 1A plus 1B is equal to 3. Just taking that top line again there. Replacing B now, so it's 1A plus 1 times, well, I know B now is 2. Okay, we just solved that up further. So let's just highlight this. There we go. So that B equals 2. There's no need to write in B anymore, just write in 2 for B. That's just 1. So it's 1A, or just A, plus 2 is equal to 3. And again, you know in your head what the answer is here. So something plus 2 is 3. And the algebra way to do this is to say a is equal to 3 minus 2. So if you bring the 2 across the equal step, it becomes a minus, and a is equal to 1, like the same answer you got in your head there maybe 2 minutes ago. Is that okay? So that's what we have, and that's the first rule here that we looked at. It's where we can add together the two lines at any stage. So let's have a look at another one here. And again, if I add together these two lines, so I have just x's and y's now. So I have x plus 2y is 5, 3x minus 2y is 7. So let's add together the two lines this time. And I get 4x, so x or 1x plus 3x, that's 4x. And 2y minus 2y, the y's cancel out, so that's lovely, is equal to 5 plus 7 is 12. So 4x is equal to 12. You can see I didn't write in the 0y because there was no need. There was also 0 z's and 0 a's and b's and c's, and I didn't have any of those written in. So if it's 0 of something, you can, but you don't have to write it in. And in this case here, I think it makes it less complicated if I don't write it in. So 4 of something is 12. How do you find 1 of that thing? And again, this is back to what we did last year. So x is equal to 12 divided by that value. So x is divided by, or 12 is divided by 4. So x is equal to 3. Okay, now we've solved for x and we need to solve for y. So go back up to any line at all you want from the start. Let's take x plus 2y is equal to 5. Let's fill in the 3 now. So it's going to be 3 plus 2y is equal to 5. So 2y is equal to Cúig or 5, Lula 3. So your do y is cormla do y is cormla hen. Sorry, y is equal to 1. Okay, that's where you are with that one. So you have x equals 3, y equals 1. So far, so good. So that was again using that first rule where we can add together lines at any stage. Okay, let's go on. And before I get on to the next problem, what if I had 1b plus, 1a, I should have had a plus b, is equal to, I'm going to say, just compare like 7. So if I 1a plus 1b equals 7, we don't have a clue. Like we said at the start, we can never figure out what a is or what b is, because there could be lots of numbers. Like it could be 6 and 1, 5 and 2, 4 and 3, or it could be decimals and so on. So that's hard to figure out. But if I was in that same fruit shop or vegetable shop or whatever, wherever I was getting these apples and bananas, if I doubled everything, I'd expect that 2b plus 2a should be equal to, and again, try and guess that number, and I'm going to say it's 14. So it should be double the answer. So if I double everything, it should be double the answer. If I triple everything, 3b plus 3a should be equal to 21, and so on. 4 of each of those should be 28. 5 of them will be 35, and each time it will stay increasing. So that's the second rule of simultaneous equations, and all simultaneous equations will be solved using those two rules. The first one is we can add together the two lines at any stage. The second one is I can multiply the line or an equation by any number. So once I multiply the whole line by that number, the values still remain the same. Is that okay? So that the values of my b and my a, what I'm looking for, will remain the same. Okay, and that's important. Okay, so let's have a look at this next problem now. So the first rule is I can add, so you can see it written down there. Again, if you want to just pause and just take this down and see how you get on yourself with it, and I'll talk through it here as well. So it's 3x plus 2y equals 5, 4x plus 3y equals 3. And this is kind of the level we're at the moment. If I try and add these together straight away, well, I'll do it very quickly. I don't want you to do this, but let's see. I get 7x plus 5y equals 8. I still have x's and y's, so I still am no closer to solving this. So I'm going to get rid of this line for a second. So we need to have a thought process now, and we need to think, well, what if I get these two y's to the same number so that when I add them together, the top y's will cancel out with the bottom y's? And what if I multiply this top line by 3, that'll get me up to 6y. And I could also multiply this bottom line by 2 to get me to 6y. So let's do that. 9x plus 6y is equal to 15. And on the second line, let's multiply this. 8x plus 6y is equal to 6. So multiply that top line by, so this line here by 3 to get you that there. And the second one, the 4x plus that by 2. And that got you that there. And we can see the main thing of that was that the y's would both get up to 6. Okay, and we spoke about us having that thought process before we start a question like that as well. Okay, so let's write out what I have now. So my new equation could be 9x plus 6y is equal to 15, and 8x plus 6y is equal to 6. Now, if I add them together at the moment, I get 12y. So maybe what I need to do is multiply this again, maybe by minus 1. Okay, that way it would be a minus 6y, and that would be good. So right out the top line, just as we had it, 9x plus 6y is equal to 15. The bottom line now, all by minus 1, so minus 8x minus 6y is equal to minus 6. And that's a very important line. That's a very important step that we need to be comfortable in doing. So let's see. I'm going to be left with 1x is equal to 9. I hope that makes sense. So 1x equals 9 there. And now let's try and solve for what y is. So y now is, let's take 9x plus 6y is equal to 15. So 9 times 9 plus 6 times y is equal to 15. That's going to be 81 plus 6y is equal to 15. So this is bigger maths, isn't it? 6y is equal to 15, but same concept, minus 81. 6y is equal to minus 66. So y is equal to minus 66 divided by 6, or y is equal to minus 11. And that would be the solution there for that. Okay, and just highlight your x and your y, just because half of your answer is back up the page a bit. And that's your final answer for that. Okay, so I'm going to stop it here. That's simultaneous equations in as tight a nutshell as I can make it. Yeah, let me know if you're still stuck and what I can do to help.